Yo, what's going on, guys? Today we're playing Calculus AP Test Edition, and today we will be looking through the AP Calculus AB FRQ number 3. So this is a separable equation. So yeah, these are one of the harder equations to solve. Now it does give us a freebie in part A. So like sketch the slope field. Just make it literally the only thing. Make sure you start from here. Once you do that, you literally cannot fail. And then you passed kindergarten. You can do that. All right. So let's get on with the real calculus. So it can be shown that so h of t is always greater than 1. And find the value of t. Critical point. All right, so the second we see critical point, right, make h prime equals 0. Let's go. So let's go. So make d of h, make that equal to 0. All right. So what we got to do here is, well, so notice how these two are conjoined together. So we can already just make each equal to 0. So you can just get rid of the 1/2. So h will equal to 1. But this isn't really showing change, since it says right here that h will always be greater than 1. So this will never be the reason the sign changes, because this will always be greater than 1. So we're not going to see any change here. This is pretty much always going to be positive, so it's always going to be positive. So let's look at the cosine t. So 0 equals cosine t. All right. So when does cosine equal 0? That's how I like to think about these, because this is really hard to do without like thinking it out. So cosine equals 0 on these points exactly right here. So at pi over 2 and 3 pi over 2, and their variance. So t can equal 3 pi over 2 or pi over or just pi. But let's think about this here. So t could only be between 0 and 5. Now 3 pi over 2, let's just make pi equal 3. So 3 times 3. That's 9. That's way out of the domain. So really t only equals pi. Right here. Since your place, yeah, you get it, right? Alright. So we got our critical point. Let's go. But the war is not over yet, since we have to find out if it's a relative minimum, relative maximum, neither. What is it? Now we could use the first derivative test. So basically making a sign chart with just this. So I'll show you how I like to make my sign charts. Let's move this out of the way. We don't need it. So we know that this function goes pretty much, well, let's not say forever, but it goes a long way. So 0 to pi union pi to 5. All right. And so we're going to make a line through here and find a number between them. So 1, 4. Simple. All right. So let's plug that in. So 1, well, actually, let's do a number besides 1. Let's do 2. So that's going to be positive. Since it's always going to be greater than 1. So that's why it's a bad number. Yeah, so it's always going to be greater than 1. It's not going to be equal to 1 ever. So yeah, well, don't use 1, okay? My mistake. So, and then cosine of 2 over 2. So it's just going to be cosine of 1. Now, this is kind of weird. I know, I get it. Let's go back to this so I can estimate it. So pi over 2 is some number. It's like 1.5. So it's going to be like somewhere here. And that x is positive, and so is the r. So they're both positive. So this is going to be a positive integer. So this is also positive. So this equation is all of it. It's big positive. All right. So now let's go to here. So this is still going to be positive since 4 minus 1 is just 3. So it's positive. Now where we get into a snag here is when we get to cosine of 4 over 2, which is basically cosine of 2. So cosine of 2. So we know that pi over 2 is like approximately 1.5, kinda. All right, so it's gonna be in this direction. It's gotta be. Notice how the x is negative, so x is positive over here, negative over here. So cosine will have to be negative since it's negative x. R is always positive though, so it's gonna be negative. So cosine of 2 is a negative number, so big fat negative. And you see positive, negative, obviously it is maximum. So good job, we did it. So justify your answer. So put something along the lines of well, it doesn't ask find the value of t. Yeah, alright, so we're gonna write it. I'll write it right here. So h of t has a relative maximum at t equals pi because h prime, well, let's use dh over dt. Let's use the same changes. Always use changes. Can't go wrong with changes. From positive to negative at, make sure you say t equals. All right. And that is our statement, justification statement. All right, so let's go on to the bread and butter, separation of variables. This is like the nemesis for most people. Sure is for me. So let's conquer this thing together. So let's get a new sheet because it's gonna require the whole page. All right. So let's just put this in the corner because we're gonna need all the space we can get. So, well, really, all right, I can just forego the page. So h of 0, the 0 is a t value, of course. So let's put t equals 0 and h value is 4. That's basically what it's telling you right here. That's really all you need. And then we'll write this equation down one last time. So it would be dh dt equals 1/2 h minus t. Oh, no, h minus 1 cosine t of 2. All right, let's get rid of this page. We got all this stuff right. All right, so let's move this h minus 1 to the other side. Let's keep this 1 over 2 here. All right, so if you knew anything about separation of variables, I hope you know at least the first step. So h minus 1, so it's going to be 1 over, since we're carrying it to the other side, we're dividing it basically. D of h, we're not moving d of h. And then 1/2 and cosine, they're still together. And then you bring this up, you times everything by d of t. So cosine of t over 2 dt. All right. So we can't do anything yet, simply because we don't know how to do any of this. We need to use u substitution. But think about it. We can't do this either. It's got this weird t over 2 thing. We got to use double u substitution. I get it. So let's say u equals h minus 1. And then du equals just dh. You could put 1 dh, it doesn't really matter. And then, so you can't use h again for this side. You could use w and make that equal this. And then dw, it's just 1 over 1/2, and then this disappears. How convenient. dt. We got a 1/2 right here. The AP testers know what they're doing. They're helping us, but sometimes we don't want to be helped. All right, so we got that. So 1 over u du. And then for this one, you get rid of the 1/2 and the dt, and then substitute cosine of u d whoops, not du, dw. Even I get confused on that a lot, but I usually fix it on my own. All right, that kind of looks like a w. Don't worry, it's not. All right, so it's gonna be natural log of the absolute value. Let's just insert u again, and so h minus 1. They're interchangeable. And then cosine of w, so oh no, not cosine, it'd be sine, not negative sine. That'd be if we were differentiating. So right here, plus c, don't forget the plus c. All right, we can exponentiate by e to get rid of this natural log, and it's gross. It's very gross, actually. And it's gonna be sine e to the sine t to the 2 plus c. Now we can just make this equal to e to the c. That's supposed to be a c. Times e to the sine t. So let's make e to the c equal to k. Let. All right. So, and then this would be h minus 1 k e to the sine of t. All right. Now here, let's solve for k. So on the top, we know that h equals 4 and t equals 0. So let's input those. So 4 minus 1, that's just gonna be 3. Sine to the 0, since 0 divided by 2 is just still 0. Sine of 0 is just 0. So k to the e to the 0. So that'll just be k times 1. So it's just k. So k equals 3. All right, let's move this. This is where we're actually going to solve it. So first of all, let's get k in there. He's been a bench warmer. Now we got to get him into the game. Right here. All right, and then you can just get rid of this, but you have to do, it's at the expense of a plus or minus. All right. And then h equals sine to t plus. All right, well, we're still at plus or minus. Not yet. So we can't have both. We can't have this. This sucks. We can't have it. So which one would it be? So t, so the initial condition, so t will equal 0. So that's going to be sine of 0, which is going to be 0. So that e is just going to turn into 1. So would it be negative 3 plus 1 that'll equal 4, or plus 3 plus 1 that'll equal 4. Well, it's obvious when I say it like that, but yeah, it's not minus, it's just e to the sine. And the domain for this is, since t will never be undefined in this, it really can't, this will just simply be the domain will be negative infinity to positive infinity. Alright, so thank you for watching. This has been the FRQ review. Bye.